So our last chapter was focusing on finding the x-intercepts by factoring. And here's two review questions. You guys can take a look at these. The first one, you can divide out the a value of 2 and then find factors of 15 that add to give you -8. So in that case, it's going to be -5, -3. So that's a quick method of factoring because you take the a value out. In the second one, factors of -9 that give you +2. So when you're brainstorming factors, 9 has 9 and 1, which one's got to be plus, one's got to be minus in order to give me a -9. And it has 3 and 3. None of those factors add to give me +2. So this one is not factorable. And now what we're going to be switching into is a concept of what do we do in this case? How do we solve for the x-intercepts if it's not factorable? Or how do we determine if there are x-intercepts or not? So what we're going to be doing now is using a formula in order to solve for the x-intercepts. This is called the quadratic formula. And in the quadratic formula, you need to have your initial equation in standard form. So the a value is the number in front of your x squared. In this case, it's going to be the number 1. Your b value is the number in front of x. In this case, it's +2. And your c value will be the number on the end. In this case, the -9. And then you plug the numbers into the quadratic formula. Be very careful with your signs. So this says x equals -b. So -b and b is +2. Plus and minus, don't worry about that. I'll show you what to do with that in a minute. B squared, so 2 squared minus 4 times a times c, all over 2a. On your calculator, you're going to simplify what's underneath the square root sign first. So 2 squared minus 4 times 1 times 9. So you end up with 4 plus 36 underneath the square root sign there. So you're going to end up with -2 plus and minus the square root of 40. 4 plus 36 is 40. All over 2 times 1 is 2. You're going to really want to use your calculator and have it handy here. This will help us make sure we're doing this correctly and quickly. The next thing you're going to do is deal with the plus minus sign that's here in the middle of the equation. So I'm going to take the plus sign and I'm going to solve for an x-intercept using the plus sign. And then I'm going to take the minus sign. So I'm actually separating the plus and minus into 2 different equations. So I will end up usually with 2 different x-intercept values. So I'm going to do -2 plus the square root of 40 divided by 2. -2 plus the square root of 40 divided by 2. I'm just going to plug that in here, plus the square root of 40. I'm going to hit enter and then divided by 2. Answer divided by 2. And one of my x-intercepts is at 2.16. So I'm going to write that down, 2.16. And now I'm going to do the same calculation, but with the minus sign. So -2 minus the square root of 40 divided by 2. So -2 minus the square root of 40. I'm going to hit equals. And then my answer divided by 2. And I get -4.16 as my second x-intercept, -4.16. -4.16. Now, as you can see, the reason we could not factor this in our warm-up is because the factors of 9 that give me 2 are decimals. 2.16 plus -4.16 are going to give me my b value, and they multiply to give me my c value. They're going to multiply to give me 9. So this one was not factorable because we're not brainstorming decimals. If I put my equation into Desmos just to double check my 2 x-intercepts, so my initial standard form was x squared plus 2x minus 9, x squared plus 2x minus 9. Equals x squared plus 2x minus 9. You can see on my graph, I get 2.16 and -4.16. So the quadratic formula is a tool to help us find our x-intercepts if they are decimals or fractions that we cannot or don't want to brainstorm in factoring. So here's another question here. And this one, my a value is 5, my b value is 8, and my c value is -10. Again, we'll just plug those into our quadratic formula. And I get b squared, so 8 squared. And I really like to use brackets to make sure I don't, if I am plugging in a negative number, I don't get an incorrect sign. So put b squared in brackets, it will make your answer more accurate, or more often accurate, I suppose. Okay, so underneath the square root sign, 8 squared minus 4 times 5 times 10. So I'm going to get 8 squared plus 200, it looks like. So I'm going to get 264. Just double check my math here. Yeah, 264 underneath the square root sign. And 2 times 5 is 10. And now this is where you deal with the plus and the minus sign. So I'm going to separate it out, plus and minus. I'm going to separate it out and put the plus at the top and the minus at the bottom. So x equals, negative 8 plus 264 divided by 10. And x equals negative 8 minus the square root of 264 over 10. And I'll plug those into my calculator. Negative 8 plus square root 264 divided by 10. Negative 8 plus the square root of 264. And then divided by 10. Gives me 0.82. 0.82. And negative 8 minus the square root of 264 over 10. Negative 8 minus the square root of 264 divided by 10. Negative 2.42. Negative 2.42 is my second x-intercept. And for today, it'd be really great practice to just grab Desmus and plug it in and make sure you're getting the proper x-intercepts. All right, and again, obvious that we did not want to brainstorm those factors. Now, not all parabolas have 2 x-intercepts. Most of the time, we've been working with a parabola that has 2 x-intercepts, so it could be like that, opening up or opening down. But sometimes the parabola can be sitting right on the x-axis. In that case, it'll have 1 x-intercept. Doesn't matter, again, if it's opening up or down here, it would have 1 if the vertex is sitting on the x-axis. Sometimes, though, the parabola will not cross the x-axis if it's opening up and above the x-axis, or if it's opening down or below, then it will have no x-intercepts. So not all parabolas have 2 x-intercepts. The options are they can have 2, they can have 1, or they can have none. Okay, so 2 x-intercepts would be like this picture here. 1 x-intercept is when the vertex is on the x-axis. That one, or none if the parabola never touches the x-axis. So the quadratic formula works most of the time. It will work if you have 2 x-intercepts or 1 x-intercept, but it won't work if there's no x-intercepts, because there's no x-intercepts, you can't solve for the x-intercepts. So if you end up with a parabola where your quadratic formula is giving you an error, that's when you have no x-intercepts. So here's an example where A is 3. I have no B value. There is no X term. So B is 0 and C is 4. Actually, in this case, you're going to end up with the vertex sitting on the x-axis. You guys try this one. You'll know because both x-intercepts end up being the exact same value. I have a 0 out front. Don't worry about that. 0 squared is just 0. 4AC all over 2A. And you'll get both x-intercepts are exactly the same thing here. Actually, no, I'm incorrect here with this one. This one is going to give us none. So here's how we'll know. When I reduce underneath the square root sign. 0 squared is 0. 4 times 3 is 12 times 4 is 48. If you try to plug this into your calculator, you get an error because you can't take the square root of a negative number. So this is therefore no x-intercepts. Try this on your calculator, you should get an error message. Let's look at what this looks like on Desmos. So 3x squared plus 4. 3x squared plus 4. So notice this parabola is opening up and it's above the x-axis. The lowest it gets to is 4 on my y-intercept here. It doesn't cross the x-axis. So this is why the quadratic formula will give you an error, because they just don't exist on the real number line. They're actually an imaginary number, but we will only work with the real number line as we talked about in our first chapter. So in this case, you're just going to say no x-intercepts or no real roots if you want to use the math terms there. So this is our quick introduction to the quadratic formula. It's another way of solving for x-intercepts. Most of the time, our parabolas will have 2 x-intercepts. Sometimes they have 1 when the vertex sits on the x-axis, and every once in a while it will have none. And the quadratic formula will help us figure out each of those different scenarios. Make sure you have your calculator while you're doing this, and just really get comfortable plugging all those numbers in and solving accurately.